Hello friends, in the past videos we saw how to use linked list as list, queue and deck, that means a double-ended queue. So in this video we will see how to operate the linked list as a stack. The stack. We know that queue acts as first in, first out. The stack acts as last in, first out principle. Let us say a hotel server holds a pile of plates, and when he distributes it to a dining table, he takes the plate which he placed last in the kitchen. That means whatever plate he placed last, that stays in the top of the stack of his plate. So when he removes, ultimately he removes it from the top. So whatever plate he placed first, that will get removed in the last. That means he need to clear out the pile of plates to reach out the last plate which is staying in the bottom. In Java, the stack data structure acts just like this. Means elements are added in the front and removed from the front. Doing so, we will end up with last in, first out principle. So here is our linked list E1, E2, E3 as usual. The push method adds an element in the head of the linked list. Then the pop method will remove the element from the head. So this is how a last in, first out is taking place. So the E4 element is the last in element, and when we remove, it got removed first. So this means here E3 is added first, after that E2, and after that E1. So when we remove, we will remove it in reverse order: E1, E2, E3. The peek method gives the element in the front of the linked list, but it won't remove the element. So this is just for the inspecting purpose. So by using the stack interface, you can make a call to these three functions: push to add an element, pop to remove an element, peek to inspect an element. Let us look at the Eclipse demo, and so you can see how we can operate the linked list as a stack. So here is the linked list example, and the product class is the same as usual. So in the previous three videos we looked about this product, so we are not digging into that right now. So here if you see, in the right hand side we created a linked list as usual, but in the left hand side we are using the deck here. Instead we can use so there is no stack interface. Previously in the slide I talked about a stack interface. There is no stack interface. The deck interface can act as a stack also. Alright, so here we are creating a 6 product: pen, pencil, rubber, writing pad, clips and a sharpener. After that we are pushing these 6 objects into our underlying data structure, which is linked list. So that means we are adding this element in the head side. That means that since we are adding pen first, at the end of the addition of 6 objects, pen stays as a last element. The first element will be the sharpener. Alright, so that's what we are doing in code snippet 4. We are pushing 6 elements. So now our linked list will have 6 elements, but these elements are staying in the reverse order. Now we are making call to the peek element just to show that we are retrieving the head element, and also to prove that the head element is not removed from the queue. So that's the purpose of code snippet 5. In code snippet 6, we are popping 3 products from this linked list. So what happens now, the elements are removed from the head position. That means we will remove sharpener, Eclipse and writing pad. If you see, this is the last string, but it got removed first. After that, clip gets removed. After that, writing pad gets removed. So here, this is just for the iterating purpose. Now let us keep a breakpoint here, and we will examine this. So first we create our linked list, then we create 6 objects. After that, we are going to add those 6 objects. If you see, pen is added, then pencil is added before pen, then rubber. So the order is reverse. If you see, it's not added towards tail, it is added towards the head. Now when we print, sharpener is printed first. Why? Because it is a stack. So just remember the piling of the plates. First pen, on top of that pencil is placed. After that, rubber, writing pad, clip and sharpener is placed on top of all this pile of plates. You can think or you can imagine like that. So now we are picking an element. That means this one will get retrieved and it is given, and that gets stored into the head. Then when we print the head, we will print 106 sharpener. Now when we pop the element, you can see here, first sharpener gets removed. That means that's the head. So the last string element is the sharpener. It will get removed first. So that's why we call it as a last in first out. Now when we pop again, Eclipse gets removed, then writing pad gets removed. After that, when I print, it will print the remaining elements in the linked list. Now rubber, pencil and pen, the remaining stuff that get printed in the console output window. So that's all in this demo. Thanks for watching. If you like the channel, subscribe it. Thanks again and bye.